my mom. She was a pharmacist and she would bring videos back home, like old video cassettes about new drugs that had come on the market. And they would be very fancy videos, like super beautiful, very colorful. You were looking at cells and drugs binding to receptors and activating these amazing, colorful pathways within the cells. I was quite fascinated by these videos. I got this inspiration to, wow, that's cool that you can actually make a drug that goes into the body and activates stuff and treats diseases. My PhD was about stroke and trying to repair the brain. I did find out in that process that it's super difficult to save neurons from dying. I mean, it's a very difficult disease to treat. I did get very fascinated about the prospect of actually making new neurons, completely regenerating those neurons that have been lost, because then we can really repair the brain. In the brains of Parkinson's patients, there is a process of neurodegeneration. One specific subtype of neurons, called the dopamine neurons, are lost. When they're lost, it has a massive impact on motoric function. Rigidity, slowness of movements, difficulty in walking, maintaining balance. We still do not have any medication that can stop disease progression. It's true that we say that you don't die from Parkinson's, you die with Parkinson's. Ideally, we would want to have a drug that could stop the disease, but we haven't succeeded. So what we're doing with the stem cell treatment is we're trying to repair the problem. We can make these dopamine neurons in the lab and transplant these neurons back into the brain. Our colleagues in the US have published data, and they actually show a decrease in symptoms in their high-dose group. And this has actually meant that they've proceeded into a phase 3 trial. Once you work with these stem cells, everything is very difficult. If you even do a tiny thing wrong, when you culture your cells, you're going to get the completely wrong type of cells. We transplant them at a very young stage of development, kind of like teenager neurons. 1 to 3 years after transplantation, these neurons will mature, send out their axons, and produce dopamine in the host brain. For many years, we were trying over and over again, making the right cells. We failed, of course, many times, until finally we were able to transplant cells into the rat. It was really learning by doing, pipetting over and over again every single week. It became a routine to me, almost like meditation, like you learn to play the piano. I'm super grateful to the patients. These are highly experimental therapies. It requires a lot of guts to go into a trial like that. For me, it was absolutely amazing the day we transplanted the first patient. I was sitting there anxious until the surgeon would call and say, transplantation is well completed. It felt like all those years of pipetting in the lab really paid off. What we would hope for in a best case scenario is that these neurons start taking over dopamine production and that the patients lower their need for medication. And it's extremely encouraging to see that these therapies are already moving into phase 3. The thought of having produced cells that are actually going into the brains of patients is, of course, fascinating, but terrifying also, because these patients have really trusted you, and now it's our responsibility to do it the right way.